Every day we rely on natural resources. When you drink a glass of water, eat a meal, or turn on light, natural resources are involved. They support daily life. Now, because we depend on them so constantly, it's easy to assume they will always be there. But when these resources are not managed well, communities can face serious problems. To see how, let's start with water. Water is essential for so many things, for drinking, for cooking, cleaning, farming, and so much more. It keeps our cities running. Now, in many places, water comes from rivers or lakes and reservoirs. But these sources don't always have enough water. I mean, especially during dry seasons or droughts. That's when people turn to groundwater. Groundwater is water that is stored underground in spaces between the rocks, sand, and soil. It acts like our backup supply. So when the surface water runs low, cities and farms pump groundwater to keep our taps running and crops growing. Now, this works well because rain and rivers slowly recharge the groundwater. But the problem begins when groundwater is used over and over without enough time for it to naturally refill. And so, when groundwater, or any resource for that matter, is used faster than they are replaced, it causes resource depletion. And so the result is water shortage. And in some places, another problem appears. As water is removed from the underground, the land above it begins to sink. This actually happened in California's Central Valley. For decades, groundwater was pumped to support farming and growing cities. During major droughts, pumping increased even more. And so by the 2010s, scientists actually measured parts of the valley sinking by about a foot per year. In fact, look at this picture. It shows how much the ground has sunk from 1965 to 2016. So over time, roads and pipes cracked, which is not a great news when there's already a water shortage. So why did this happen? Not because people were careless. It happened because the groundwater was used without a long-term plan that matched how quickly nature could replace it. So how do we solve resource depletion? Well, we carefully plan how the resources are used so they last. In California, in 2014, new groundwater laws were passed. It required regions to monitor and set limits and manage groundwater as a shared resource. So if we zoom out, the solution to resource depletion is not stopping the use altogether. That wouldn't make any sense. So we're not going to stop using groundwater, but the idea is to stop overuse and make sure that it stays available for the future. Now, guess what? The same pattern shows up with energy as well. You probably know electricity powers lights and refrigerators and schools and hospitals and so many things. When electricity is reliable and affordable, daily life runs smooth. But when people don't have dependable or affordable access to electricity, we get energy poverty. Power may only work sometime, or it may cost too much, or stop completely during emergencies. Again, a clear example happened in Texas. In July 2024, Hurricane Beryl caused widespread power outages across the southeastern Texas. Millions of people lost electricity as the main grid was damaged by wind and flooding. In many areas, power stayed out for days. But some places kept electricity. How? Well, in Houston area, for example, buildings were equipped with something called solar microgrids. They continued operating. What do? Well, they use solar panels and batteries to generate and store electricity locally. And whenever the main grid fails, like it did during the storm, the stored energy kept supplying the power. Now, sure, these microgrids didn't solve the entire outage, but they reduced its impact. They also reduced the reliance on diesel generators, which are expensive and also cause air pollution. Look, this is why energy resource management matters so much. Planning where and how energy is produced helps make electricity more reliable, cleaner, and more affordable, especially during extreme weathers. Food systems also depend on natural resources, and when these are not managed well, it can cause malnutrition. By the way, malnutrition doesn't just mean not having enough food. I mean, that's there, but it also includes food that lacks nutrients. Remember, nutritious food requires healthy soil, clean water, for example, stable ecosystems, and so many other things. But when these resources are overused or damaged, food systems can become pretty fragile. Again, let's take a concrete example. For many years, fertilizers from farms across the Mississippi River Basin were washed into the rivers and carried into the Gulf of Mexico, also known as Gulf of America. Now, these fertilizers contain nutrients that help plants grow. So when large amounts of these nutrients enter the Gulf, they caused algae to grow very quickly. Thick layers of algae spread across the water. But then, as these algae died and broke down, bacteria used up oxygen in the water. And as a result, by the early 2000s, scientists observed a large dead zone forming each summer in the Gulf of Mexico, where oxygen levels dropped so low that fishes couldn't survive. As a result, the fish population reduced and made fishing less reliable for the coastal communities over here. So again, what was the problem? It wasn't a single farm or a single choice anywhere. It was the result of the soil and the water systems that allowed the nutrients to wash away instead of staying in the ground. Resource management over here would be keeping the soil healthy and keeping the ecosystems balanced. For example, practices like crop rotations or reducing erosions and limiting how many fishes can be caught each year, they all help food systems remain stable. So in the Gulf of Mexico, that meant changing how the nutrients were managed upstream over here. The states along the Mississippi River began restoring wetlands and encouraging farming practices that keep the fertilizers in the soil instead of just letting them wash into the rivers. Now, these changes didn't eliminate the dead zone overnight, but they helped reduce the amount of nutrients that would reach the Gulf. And so the whole point is to try and make the system more resilient over time. So if you zoom out, look, malnutrition in this sense is about systems and access. It's not personal failure. Okay, now guess what? Natural resources also affect air and water quality. Pollution happens when harmful substances enter air or water faster than nature can handle them. Poor resource use often makes this worse. Again, concrete example. In cities like Houston, heavy rains can cause stormwater runoff. What this means is that water flows over roads and parking lots and stuff, and they pick up oil, trash, and chemicals before eventually washing into the rivers and bays and polluting it. In fact, after major storms, water quality in places like Galveston Bay has temporarily dropped because of this polluted runoff. This can harm wildlife and make water treatment more difficult. And guess what? Energy choices affect air quality too. I mean, burning fossil fuels, for example, release pollutants in the air. In contrast, cleaner energy sources like solar or wind reduce air pollution because they don't burn fuel. And so if we zoom out, we use natural resources every day, but they are limited. Problems arise when these resources are used faster than they can recover, or when systems aren't designed for long-term limits. That's why resource management is the way ahead. That's how societies should plan. It doesn't eliminate challenges overnight, but it reduces harm, it improves reliability, and supports people's well-being.